So I'd like to welcome you all to this panel event that we've organized on the neuroethics of whole brain emulation. And I'll put a bit of context here. The Carbon Copies organization has been around for a while, and our focus is on this topic of whole brain emulation and how to get there and everything related to that. So we are a research and education nonprofit. And on the research side, we are currently mainly doing two things. There is this project about the neuroethics, and there is a project called the Brain Emulation Challenge, where we are trying to develop a system that will make it possible for neuroscientists to test their best methods at translating from the data they're collecting from the brain to reconstructions that should capture what was really going on in that brain tissue. We also have an education component where we're trying to do outreach and explain to people everything that we understand so far about whole brain emulation, what it's about, etc. Now, a little while back, we started this project to create a framework for the ethics of whole brain emulation because we felt that it wasn't fully covered by previous attempts to address the ethics of, say, neurotechnology or neuroscience or anything related to that. And because we wanted to begin by collecting information, by learning from other people what the problems might be, what we might have to consider, things that we wouldn't think of because we're too narrowly focused on the topic, we decided that we were going to organize some events where we would attempt to discuss specific topics, problems that might come up, things you might imagine that would happen, and that we would do this with some experts who have different backgrounds. So for example, backgrounds in economics or backgrounds in philosophy or backgrounds in, say, military strategy or what have you. And this is the second event of that kind. The first one was kind of a test in the sense that we weren't sure how the format was going to work and what we were going to do, but it worked out fairly well. So this time around, we've invited a round of wonderful guest panelists who have their expertise in the field and who are going to be sharing that with us. And Anders Sandberg is going to be our moderator today. He has some prior experience moderating somewhat similar things, so I hope that's going to help out, but I'm not going to try to put too much on your shoulders right now, so I won't say much more. I think at this point you can take over and we'll get going. Thank you.
Well, thank you, Randal, for starting this. Yeah, so I have been involved, of course, with brain emulation for a long time, as have many of you. Indeed, a fair number of you were even present back in 2008 at that workshop we had over in Oxford. Some others of you have been present in the other workshop we had in Oxford in 2023, I think. And some of you in the other in the more recent workshop we had a few months ago over in Berkeley, or co-organized with the Foresight Institute. So basically, one of the interesting things with brain emulation is that on one level, it's a speculative technology, something we in the philosophy department and science fiction writers like to think about. But it's also a fairly clear goal for various fields of study. And so it actually makes sense to figure out things beforehand. In a lot of cases, we need to figure out pathways where we want to go, but also quite often, why do we want to go there? What's in it for us, where us might be humanity or us people living right now, or for science or industry. And ethics is quite an important factor here because it deals with values, what paths you're allowed or not allowed to take, what might be wise or unwise to do. And usually when the people think about the ethics of speculative fiction, they go into what Robin calls far mode. We tend to quite often project things onto grand principles and not be too terribly concrete about it. And that's sometimes very useful, especially when you're very uncertain about things. But it might be useful also to think about things in near mode, and on a lower construal level, as a psychologist would say, actually thinking about the more concrete problems to build up a richer understanding of, okay, what are we perhaps going to encounter? What do we need to deal with when thinking about these questions? So that's kind of my already way too long preamble. So the goal right now is, of course, to get going on thinking about the different topics. And Randal has set up this document with topics that came up in the email conversations. Some of you have also prepared a bit other material. So I don't know quite how we'd make a proper list here where the people who want to give a little spiel present that. I don't see a natural ordering here, but Randal has raised a hand, and given that he's kind of running the server, he totally gets priority.
No, I thought I might just help out with how we can do this, because we're going to do a round of introductions anyway. So we can just go through the introductions of the panelists, and then, normally a panelist would maybe give a 2-minute introduction themselves, but if someone has a little talk to give, then they can do that right there. How about that? So we just work through that way. And you can pick the order, since it's whatever it is on your screen, pretty much, of our panelists.
Yeah, that might actually be a useful thing. Now, I wonder, am I seeing the full set, for example? One of the things I worry about with online meetings is that the layouts are so fluid, and I always fear losing out on people when they reorganize themselves. But maybe we can try this and see what happens.
Do you need the list of speakers so that you can remember how to go through them? Maybe from the flyer, or no?
That might be a good idea, because otherwise I'm not certain who's supposed to be speaking or not.
Although, do you have the link
everybody.
handy?
Sorry?
Mirinda, do you have the link for Anders? Give him the flyer there.
Yep, I'll put it in the chat, or I'll email it to him.
Oh, yep.
Awesome.
Okay. Anyway, since I'm just first, I can just use this chance to say that I'm Anders Sandberg, academic jack of all trades, former computational neuroscientist, worked for 19 years at the Future Humanity Institute. Now I'm at the Institute for Future Studies in Stockholm, and everywhere else too, actually. But in Stockholm, I'm at the Mimer Center for Long-Term Future Studies, where I'm one of our topics is brain emulation, philosophy and ethics. I'm also involved in some of the foresight projects. So yeah, generally interested in everything here. And I have written a paper about brain emulation ethics a bunch of years ago. I have some notes that are not in the list of topics, but I don't think they're as high priority as the topic list we actually got. So I'm not going to foist them in there. We might want to do that later. Okay, so what ordering will I do? Okay, I got it emailed. That's brilliant. And then, of course, because of Google's new system, I actually got the poster properly. That's cool. Okay, so in that case, the next person on this list would be Randal.
Okay, then. Hi, so I did not prepare a little talk, so I'm not going to spend 10 minutes. I'm just going to say I've been involved with this whole brain emulation field for quite a long time, as Anders has. We were both involved with that project back in 2008. And my work on this actually goes back even further than that. My input on it, though, has been largely on the side of trying to track what the technical means are to accomplish whole brain emulation, which path you would take, and to keep on trying to address whichever gaps appear there. So in the very recent time, I'll just skip all of the past. It seems that the main thing that currently is needed is this thing we're calling translation, or the translation problem, because there are now some really good data sets available, at least in terms of collected connectomes and annotated connectomes, data structure like that. So there's the entire fruit fly brain, there are multiple cubic millimeters of mouse brain, there's a cubic millimeter of human brain. All of this scanned at a resolution where you can reconstruct the cells and look at the cells. But when we say reconstruct the cells, typically what we mean is look at them in 3D, maybe identify what type of a cell it is, but not really create a working model from that, where you have functionalized it, where you've taken this cell you're looking at and saying, okay, we're going to use this model to represent that cell, and the exponentials in there need to have those parameters. So this parameterization and doing that correctly for all of the components of the brain, such that as you go up level by level by level, and you apply some constraints to the neural coding that's being used, that you still want to get something that not only works and isn't epileptic, but something that actually is what you've been scanning. So that contains the memories that would have been there, or the characteristics of, say, that animal that you scanned, all those things. So this translation problem has been our most recent focus, and that's what takes up most of my time right now. But at the same time, I'm also really interested in this issue, the neuroethics surrounding whole brain emulation, because I realize that I keep bumping into questions where I wonder, oh, I wonder what this is going to be like and how this is going to affect the future, how this works very differently from what we take for granted right now. And I realize that I don't have enough time to just really think about that clearly. So I'm trying to learn and absorb from everyone else here. And that's pretty much why I'm here now. Thanks.
Cool. So then Florian.
Thank you very much. Yeah, it's great to be here today. Thanks for the invitation. I was really looking forward to that. So I'm new to the round. I'm very curious about everything that I can learn today and hopefully also contribute something. My name is Florian Neukart. I'm with Terra Quantum. Terra Quantum is a quantum technology company focused on developing any quantum technology in both hard and software. So that comprises quantum computing, sensing, imaging, cryptography, medical devices, combining the old quantum technologies such as lasers with the new quantum technologies such as quantum computers, and see how we can usefully apply them to solve complex problems. Besides, I have been working as a professor for quantum computing at the University of Leiden in the Netherlands. I'm calling in from San Francisco today, so that makes it always interesting to teach sort of a comet-like existence in Leiden. But I've been doing that for so long and wouldn't give it up. Anyway, so my private research or personal research interest, and that I'm also pursuing at the university and partially also at Terra Quantum, is in the space of learning systems. So I don't come from the field of whole brain emulation, but so what I've been concerned with for a long time now is thinking about how to learn from data. And that started with all the classical systems that we have. And usually people that have some physics background, they will also try to incorporate quantum physics at some point, which is hypothetical. So if that plays a role in biological systems and if that plays a role for cognition, but we can make an assumption and could make more assumptions, even think about where in the brain it would make sense to do that. And that leads us to quantum neural networks, for example. So systems that learn from data still, but then use quantum effects to encode these systems, this data, and then improve learning. And then even more, when you think about the functionality or how neurons function, the question comes up, how would quantum effects potentially play a role there? Because everything in the universe, as we currently understand, is based on quantum physics. So an assumption that one could make is also biological systems and then also neurons, but where in the neuron may this play a role, and then try to simulate that accurately and potentially even think about systems that could mimic neural behavior exactly. And that's another stream that I'm pursuing, which is thinking about very small machines, nanobots, that could potentially attach to neurons and then potentially replace neurons even. But still, there are many open questions. There are many open questions as to interna of how neurons work, where the quantum effects make this transition to classical behavior, if that is at all required to mimic that behavior. But the idea of that whole work being now to gradually replace parts of the brain and continue the stream of consciousness, so to say. And there has been a very interesting discussion in this email thread going on. So thanks a lot for the comments and additions made. I'm very much looking forward to continuing that and ideally continuing that today as well. Also, I have not prepared a talk. So much to me and my current interests and work. Thank you.
Thank you. Okay, next on my list would be Henry.
Hi, very nice to be here. So I'm Henry Shevlin. I'm the Associate Director of the Leverhulme Centre for the Future of Intelligence at the University of Cambridge, and I'm a philosopher of cognitive science and an AI ethicist. I've spent most of my academic career working on the science of consciousness. I did my PhD at the Koene Graduate Centre in 2016 with Peter Godfrey Smith, who may be familiar to some people, for his work on animal consciousness and animal cognition, and that's been a focus of a lot of my research, particularly measurement of consciousness and suffering from a welfare angle. For the last 7 years, though, I've been focusing, well, still a little bit on animals, but increasingly on AI systems and questions around AI consciousness, which I think are increasingly salient, particularly in the post-Blake Lemoine era. I'm sure that's a name that's familiar to most people, but in case anyone doesn't know the name, this is the Google engineer who went public in 2022 with claims that Lambda, a precursor of Gemini and Bard, with claims that this system was conscious or sentient, and he was later fired after seeking legal representation for the system. So I think the general consensus in the consciousness community was that this was a premature call for AI rights, but I think it nonetheless gave us an indication of what lies ahead in the years to come. I would also add that a growing segment of my research is on social AI systems, as I call them, so AI companions, most famously romantic companions like the service Replica with a K, but I think a wide variety of AI systems, predominantly large language models, are increasingly being used in social contexts. And I think this helps define a context for thinking about whole brain emulations, why we might develop them, what they would be used for, and whether the ethics of whole brain emulations should be significantly different from the ethics that we apply to large language models, particularly those trained on individual people to simulate their identity. By the way, this is something that's already happening and I think is an interesting issue in its own right. We've had several Instagram and TikTok influencers now release fine-tuned subscription models so people can have one-on-one friendships or romantic relationships with AI systems trained to resemble their particular quirks and idiosyncratic conversation style. Right now, as I understand it, there is very little legal protection to prevent a third party releasing a large language model trained on someone else's social media utterances. So I think this is all creating a really interesting and quite worrying set of legal quandaries that in turn will shape the context for ethics of whole brain emulations. And I'm looking forward to chatting more about this with everyone here today.
Cool, great. Next on my list is Keith.
Hello, I'm Keith Wiley. I'm probably best known, if I'm known at all, for my 2014 book on mind uploading, which was a two-parter. The first part basically presented a very long list of thought experiments about mind uploading that basically provide a sandbox for anyone to sort of test their own beliefs and theories against. And the second part of the book was in advocacy and defense of the branching interpretation. Based on a psychological model, basically memory-based identity with very little sort of flexibility for other priorities. After that, I've written a number of papers, one published in the Journal of Consciousness Studies with Randal, which all are essentially continuations of that same line of reasoning. I currently work on the software side of connectomic reconstruction of sort of ultramicrotome slices and neuropill sort of 3D reconstruction, and then the actual connectomic circuit inference. So that's the space in which I work when I'm not a philosopher. And sort of pertaining to ethics, I don't really get into ethics too much, except that again, sort of my relenting advocacy for branching identity is it's nothing but an ethical claim about sort of where I think the various resulting persons from these procedures sort of stand in the ethical landscape. I think I'll leave it there.
Thank you. Yeah. So next on my list is Robin.
Hello, everyone. I'm Robin Hanson, author of The Age of M, Work, Love, and Life When Robots Rule the Earth, which I wrote in 2016. Honestly, I think it's the most detailed analysis of the social implications of any technology ever. But soon after the book was written, interest declined, and I really haven't seen much interest from the world about it. So I've been doing other things mostly. And so I'm happy to return to the topic here. What I want to say is I thought a lot in the book about what were the things that you should worry about. So basically, the future will mostly take care of itself. When we think about the future well ahead of time, the main thing we should be doing is asking, what are the exceptions? What are the few places where doing things early could make a big difference? Because most everything it won't. And in my judgment, the thing that would make the biggest difference to do early is to try to ensure that EMS and biohumans are integrated and share systems of law, governance, finance, etc. Because there's the fear that if they are just created as a separate society with separate everything, they will see themselves as separate, and then there'll be much more opportunity for conflict, and they would win such conflict. So don't pick a fight you can't win. Don't pick a fight, like integrate them. And I think that's a problem for the sort of framing of this event or things like this, because if we ask what are the ethics of EMS, then I don't think we're cutting nature at the joints. That is, there are many topics that EMS are relevant for in ethics. There's inequality, aging, governance, privacy, medical ethics, population, even agent similarity. And I think each of those topics should consider EMS as one of the scenarios that they try to integrate into their framework and analysis, but they should just be trying to make a general analysis that's robust to EMS, including everything else they can be robust to, and not trying to make EMS-specific ethics. I think trying to make EMS-specific ethics will tempt people to make EMS-specific regulations and EMS-specific institutions and everything else, which is exactly the problem, the wrong way to go. And so I might say, well, if we're going to talk about something here, I might ask, okay, among these various ethics topics, which is the one where the existing literature on that topic least includes something like EMS, i.e. is the least robust to including EMS, and let's help that literature include this is one of the scenarios they use to generate a robust general approach. That would be, the effort we could do to not make a separate field of ethics, but to make this one of the standard scenarios that all fields of ethics should be trying to include, because it's a likely future outcome that their ethics will need to encompass. Anyway, that's my bit.
Cool, thanks. So next on my list is Tim.
Hi, everyone. So I'm Tim Campbell. I'm a researcher at the Institute for Future Studies with a background in philosophy based in Stockholm. And I'm also with Anders at the Mimer Center for Long-Term Futures Research. So in the past, I've worked mostly on population ethics and animal ethics. And whole brain emulation is a topic that I sort of recently became interested in. And I did prepare a little talk, which I hope I can give. There's already been some discussion about this in the forum, but let me, let's do entire screen. Am I able to share? Hold on a second. Let's do entire screen. Okay. Okay. So I spend most of my time, or until recently, thinking about how we should value populations in which the number of people and their welfare levels may vary. There are different, views about this that people argue for in the literature. So some people like totalism. They say the value of a population is the sum of the welfare levels of the lives in that population. I mean, people's lives. So you look at all the people, you see how they're doing, and you sort of add up to derive how good the population is. Some people like averagism. The value of the population is the average of the welfare levels in the population. And a third view that I'll hear, that I'll briefly talk about here. Critical level totalism, value of a population. X is the sum of all lives' contributions to X, where the contribution of each life is its welfare level minus a critical level, C, where C is higher than the neutral welfare level. So the idea behind this is that a life needs to be sort of sufficiently good, not just good, to contribute positive value to an outcome. People who like this view think it would be bad if you had a population with lives barely worth living, let's say, people eking by. And there are a lot of other views. There are views that try to incorporate, inequality and so forth. There's a proliferation of views and a lot of debate in this area. And so what I want to do in this brief talk is sort of pull together two parts of philosophy. So this part, which has to do with valuing population, with another part of literature, which has to do with individuating lives or counting people. So let's suppose that lives are made up of different temporal stages, right? So there's a stage of your life that began this morning when you woke up and will end when you go to bed tonight. There's a stage that started to exist when this meeting started and will end when the meeting ends. And think about this as just different moments within the life. And suppose that in ordinary circumstances where we aren't replicating minds, two of these life stages are part of the same life, or part of one person, just in case they're appropriately psychologically continuous. And suppose with any reliable cause. So the exact understanding of psychological continuity doesn't really matter for these purposes. There was some debate about what the right kind of cause is to preserve personal identity in the forum already. So the diagram below represents a situation in which the mind of an M, so we're already dealing with population emulations here. We're not thinking about biological people being uploaded, but the mind of an M is replicated. So here we've got some stages, some life stages, we'll call them X and Y, and X is at time t1 and Y at time t2. And then a replica of the mind is made, giving rise to a new stage, Z, which also exists at time t2. And we'll suppose that X is psychologically continuous with Y and also with Z, but Y and Z are not psychologically continuous. So we've got these stages, and the question we can ask is, how many lives are there here, and where are their temporal boundaries? And there are three answers to this, at least three answers to this question in the literature on personal identity. These are not exhaustive, and since I have only a brief time, I'll just talk about three. So I'm using boxes here to sort of show you where the people are. So one thing you could say is there are two separate lives. So X and Y are stages of one life, and Z is a stage of a separate life. And this kind of fits nicely with the idea of the way people talk sometimes about an original person and a replica person. So you think of the life with stages X and Y can be treated as the life of the original, and the life with Z as the life of the replica. Second answer that we could give, which is also defended in the literature, is that there are two partially overlapping lives. So X and Y in this case are stages of one life, and X and Z are stages of a different life. And these lives overlap in the sense that X is a part of both. A lot of people think that this view is really weird, so I just want to mention that this view does have some defenders, and I list them here. Happy to share these references afterward. And then finally, we could think that there's a single divided life. So X, Y, and Z are stages of one life. This life is divided since two of its stages run in parallel. So the life is this oddly shaped thing that has all three stages. And what I want to suggest is that combining these different answers to the question how many lives there are with views like totalism, averagism, or critical level totalism expands the range of possible evaluations that we could give of a population. So one way to show this is just, again, take this case, except add some assumptions about welfare in these different stages. So these numbers just represent, units of welfare. Say it's something good is happening in each of these stages. So it could be like momentary pleasant experiences, if you think emulations are capable of experience. It could also be things like momentary preference satisfaction, and they're distributed like this with 1 unit at each stage. And the table below kind of represents the idea that we can have different evaluations with the different criteria for evaluating a population going across totalism, averagism, critical level totalism, and different ways of individuating lives that I just mentioned going down. And so for critical level totalism, just assume somewhat arbitrarily that the critical level is 2 units of welfare. So a life with welfare 2 is right at the critical level. Lives below that contribute negatively to the outcome or the population, and lives above it contribute positively. So on the 2 separate lives view, totalism is fairly straightforward. You just take the total welfare for each of the people or each of the lives, and you add it up. For averagism, again, you just add them up and then average over 2, the number of people. And for critical level totalism, since the critical level is 2, you look at each person, and in this case, you'll have one person who's right at the critical level and another person who's below it, which comes out to -1. This is a bad outcome. If you go with partially overlapping lives, then you get a different answer. So totalism will give you that there's a total of 4 units of well-being. So you count one person consisting of X and Y, and then another person consisting of X and Z. X is counted twice because it's a part of 2 different people. For averagism, you do the same thing, count the people and then average, take the average. And for critical level totalism, you count up welfare and then see where those people are with respect to the critical level. And then finally, for the divided life, again, for totalism, you just count up all the welfare of the stages. For averagism, there's only one person, so it'll give you the same answer as totalism. And for critical level totalism, you'll have one person who's just barely above the critical level by 1. So the idea is basically that you combine these different ways of counting people with these different criteria for evaluating populations, and you get kind of a proliferation you get a lot of different choices about how to evaluate outcomes. And yeah, I guess that's basically that's basically it. There are, a number of things that you could say to, in response. You could try to pick your favorite view of how to count lives. And your favorite criteria of evaluation, and argue for those. You could do something that Rob and Hanson suggested in the forum on the discussion of this beforehand. You could say, well, you don't care about people in their lives necessarily, but you just have, as long as you have the stages or the moments and their values, you can use that to derive the value of the outcome. So on that sort of view, all this just looks like a kind of gerrymandering. And a third approach you could adopt is you could say that you're uncertain about all these things and try to do some sort of expected moral value calculation, plugging in different credences for your beliefs and how many people there are and what the right criterion of evaluation is. But anyway, this is just a problem that confuses me. And so I thought I would just drop it on you without necessarily offering a solution. And that's it.
Thank you very much. So before we move on to Henrik, Logan has a question here.
Yeah, thanks for the interesting presentation. I was wondering, so when I've thought about population ethics, and admittedly I have very little experience in this area, I've thought that a lot of the paradoxes might be, if not resolved, at the very least reconsidered if one considers the entire universe to be one individual. sort of a interconnectedness kind of perspective. And I was wondering, just do you know, as somebody who does research in this area, do you know anyone who has written papers on that kind of idea or anything like that?
There is a person. His name is Arthur Zuboff. He doesn't publish a lot, but I believe you can find something from him probably on the internet. He has a paper where he argues that what appears to be every person is identical to every other person, and he has an argument for that. It's very far out there.
Sure.
That may not quite be the kind of monism or monistic view that you had in mind, but I don't know that he has discussed this at all in relation to population ethics. But I think you're right. If there is just one person, then populations don't change in size. There's always just one, and we don't have to talk about whether creating new people should be considered a special case different from improving the lives of currently existing people, because there's only one person, the number of people don't change. I don't know anybody who has sort of defended that view, but that's very interesting.
Yeah, I've just thought it could be an interesting idea to explore and see what the implications are. But yeah, thank you for the input there.
Thanks. So, Henrik, would you like to present yourself?
That's me. Okay. My name is Henrik Örström. I am a old school transhumanist from the early 90s. I'm currently working as the head chief anesthesiologist at a small hospital in middle Sweden. I'm responsible for the production there. It's the region of Örebro. I'm also medical technology, responsible for the medical technology branch in the local hospital region. I'm working with anesthesia and intensive care and branching out in pain medicine regularly, mostly for acute pain and terminal pain, not so much chronic pain. And I'm used to rebooting central nervous systems on a daily basis. So I've been looking at this from my rather hands-on perspective, assuming that all this works, that we can scan a brain, then what? Is it just to scan it and everything is happy? And I've been quite worried about when we scan a brain, we get all the status that we have at the moment of scanning. And I am worried about the fact that it's probably not just a matter of commenting out the problems. So if you have a person with problems that you are scanning, then the scan will have the problems. And the problems is probably not trivial since you're scanning the person, especially if it's a destructive scanning. Then the patient is probably dead, or at least he will be. So we have, assuming that we are having a destructive scanning, which probably actually is less destructive for society, but that's another problem. If you have a destructive scanning, and you're scanning a person who is dying in cancer, with pain, high levels of anxiety, is that a nice way to start your scanned life? Could be a problem. And I've been reading a lot of comments in the background materials about commenting out pain. That would be nice, right? The problem is it's probably not possible because pain is not just one subroutine. It's a lot of stuff. And I propose that it will be a large problem. Also, if you scan someone who has psychosis, then we have scan with psychosis, and Psychosis will tie into attempts to mitigate your pain problems. Because if you manipulate sensory input too much, you will get psychosis. Phantom pain is one kind of psychosis. And yeah, it's not trivial to edit it out. So if you start out with psychosis, it will probably be worse. And then we have the problems with if you have a person who's been run over by a steamroller, you're looking at him in the ER, and yeah, this one is dead. But we have the scanner over there. Should we just dump it in? What does he want? Do we know that? Robin Hanson writes, well, yeah, you have to make a decision about, do I want to be scanned? Like you have, if you are sick, you have to make a decision about, do I want CPR? So you have to make a life testament or a life, what do you call it?
A living
will, in which you specify, do I want to be scanned or not? If the patient is a small child who's dying, should we scan that one? And so on. The problem for this panel is that I'm not thinking about this daily. So apart from a lot of the dystopian fantasies in the on the subject, I haven't written anything about it or something. But I have written some comments in the shared document. So that's my presentation.
Well, thank you very much. I think this is a good example of a very concrete ethical problems where population ethics is kind of on the opposite side, where we're all drawing various rectangles on the whiteboards representing different populations. But then we have a problem in the ER. What do we do if we have a technology but are uncertain about quality and consent? Okay. Is there anybody else who would like to present and give a small talk, or should we move into the main conversation?
I think if we've had all the speakers, all the panelists, then it's probably time to get into the topics. Yeah.
Because we spent 50 minutes doing this, although it's been, at least for me, very interesting.
Yes, it has. Yeah, it definitely has raised some issues that I had not even considered thinking about. So I'm very glad to hear those. Mirinda, I hope you can also pop up the slide for a particular topic, just as kind of a helping hand if, if it's along that line. Like, I know that, Anders, you have the freedom to go in whichever direction you want with this, but if we're following that, then Mirinda could pop up the slide.
So, so the document I have in front of me have various ethical points, and they don't seem to be following any particular time ordering. So if I imagined doing this, I might start out with near-term stuff and then move to more long-term stuff. That's not necessarily the best layout. It might actually be interesting to jump a bit around, although that is also likely to create issues about what assumptions do we make in different scenarios. But if everybody's fine with doing that jumping around, I think it might be refreshing, because otherwise we're always going to be start on the what about our virtual lab animals? How do we treat them, etc.? What about those poor in leaky integrate and fire fruit flies? Do we need to give them sugar water in their simulations all the time or not? So I think we might want to start actually then at the top with the future of work and ethics of human cognitive enhancement, which in some sense, it's a very standard question. We get it in the AI debate, of course, all the time. What if AI changes employment situations? And the debate about human cognitive enhancement is also somewhat well-trod ground. We have been kind of arguing that in academia for about 25 years. But there might still be interesting points here where we might aim at finding what Robin looks for in those questions that actually make it slightly more unique. I would like to point out that one key thing is we get copyable human capital. That seems to be economic plutonium. That's kind of obvious where something very important happens. And similarly, commenting out pain might, okay, that's probably way too facile. But I do think that you can probably actually, by having access to a neural network and developing tools for manipulating that, probably make some virtual painkillers that are going to be pretty astonishingly good compared to the chemical painkillers. But I love to hear your views here. So, okay, Randal started here.
I just wanted to, I mean, kind of going back to the preparation that we did just before this, if Mirinda can briefly read out the topic, that helps anyone in the audience who hasn't had the privilege of seeing those topics before, as we have. So maybe Mirinda, if you're still there, if you're on, are you able to read it out?
Yep, I'm here. So should I maybe share the document?
Yeah, sure. Yeah, pop it up on screen.
Yep. Looks good. I think it's somewhat readable.
Okay, great. Let's see here. All right, so the first topic is future of work and ethics of human cognitive enhancement. In the future, emulations may possess considerably more advanced cognitive and problem-solving capabilities than those of current biological humans, including enhanced reasoning, information processing, problem-solving, and general work productivity skills. Emulated minds could exist indefinitely in a digital environment free from the biological aging processes. Can you speak to how these cognitive enhancements accompanying whole brain emulation will change the future of work once whole brain emulation technology is fully introduced into society? What are some significant ethical concerns posed by these advanced forms of human cognitive enhancement? Do you think digital uploads should be allowed to enter the workforce and hold jobs alongside biological humans? In your view, how ought we to best prepare for the cognitive enhancements in order to ensure that whole brain emulation benefits the future of work?
Okay, great. And Robin was early out here, to nobody's surprise. Please, Robin, take it away.
Hi. As I analyzed in my book, Age of M, a relatively free market labor market, but I do think that's usually our default. I do think our default is to let different people compete in different labor markets as best they can and choose whatever training regimes they have, and M's would then, by that standard, be allowed to compete for jobs. I think, the standard observation has long been, about AI and M's, they could outcompete the rest of us. We face a risk there. What do we do about that? That's a risk issue. And I've been long suggesting we should just set up insurance against this risk. Humans will collectively own pretty much all the capital in this world. And even if they lose their jobs, if the economy grows very fast, their wealth would grow very fast. So they could do very well as long as they have a substantial fraction of capital, not just labor. And a way to do that is to set up ex-ante insurance. And it doesn't even have to be individually underwritten insurance. You can just have an asset, say, take a stock index fund and split it according to whether or not the labor force participation rate falls from, say, above 60% to down below 20% in some period. If it does, that would be the signature that lots of people have lost their jobs. Then that part of the asset pays out. In that case, the other part pays out if not, and you can just buy these assets as a way to insure against future labor market risk. It would be cheap now because the odds would be so low. So rather than trying to prevent M's from competing in the labor market, I would just say, let's let people insure against this risk, because overall it would be better to have a much more productive economy where M's can do all the things they could do well, and individuals who face risks, let's let them insure.
Great. Henry?
Thank you. So this is partly a question for Robin, but also the rest of the panel. And I think what the question boils down to is the question, how much has the last 3 or 4 years of developments in AI shifted our priors about the likelihood of whole brain emulation playing a significant role in the future of the global economy in the near term? I mean, my sort of starting point on this is that I think evolution is really overrated, or biological evolution using DNA replicators is very overrated. It's very bad at exploring search spaces. We tend to look at the successes of evolution and ignore the fact that a lot of really successful adaptations like eusociality in insects, for example, arrived incredibly late in evolutionary terms. But once they were in place, we see convergent evolution across multiple lineages. So my sort of hunch is that human brains are a very bad way to build intelligent actors. It's sometimes said that we're the dumbest species capable of complex, large-scale technological societies. So I think probably to my mind, over the last 3 or 4 years, the surprising success of transformer models has made it increasingly likely that the near-term, say next 5 to 10 years of impact of artificial systems on the economy is going to be through models that may be anthropomemetic at the kind of coarse-grained level, but actually function according to very different principles, are not particularly like human brains. And that rather than thinking about whole brain emulations, we should think about, digital transformer agents or whatever the sort of successor technologies of transformers are. That's not to say whole brain emulations, of course, won't happen. There are lots of other reasons we might be keen to build them, whether for research purposes or in the pursuit of personal immortality. But I guess my default position, though I'd love to hear from the rest of the panel if they have other views on this, would be that whole brain emulations are unlikely to be the specific vector by which AI has major disruptive effects on the global economy. And I'd love to be challenged on that.
Cool. Yeah. So Randal.
Yeah, I'm going to say something straight that belongs right with what Henry was saying, and then kind of make a, I don't know, statement, comment, whatever. So I actually agree with Henry. I think that there's absolutely no evidence that says that whole brain emulations would be the best candidates for doing any type of work. Like, why would you use that if you can make an AI that is much more well suited for that particular type of work that you're trying to do, that is really engineered for that purpose? So that's one thing. That's just from the point of view of, okay, who do you need to fulfill a certain job? But there's this whole other side of things that to me seems important, because it's the reason why I got into this whole thing. Like, I'm not working on whole brain emulation because I want to create a better worker. I'm not into whole brain emulation just because, I don't know, I need to know how we're going to survive the future of work. But I think that this is a way to explore growing as people, as a species, doing things in a different way, better way, improving the future. And so when I think about work, I think, okay, I do a type of work. I do projects that I care about. That's the sort of stuff that I do. I want to work on my projects, and that could be exploring something, it could be building something, creating something, whatever. And that is, to me, completely different from, say, having to work to make money to live. And so I guess my question going into all of this sort of future talk is, are we just talking about this as we need to be worried about, whole brain emulation or AI taking away jobs because people need jobs to survive, because everything is always going to be the same? The future is going to be like the now, and we all have to work so many hours a day to survive so that we can just make it through? Or can we get to a future where perhaps, yes, we build AI that is perfectly suited to making sure we all have plenty of resources to survive, and we can spend our time on the projects that we care about? And that was my diatribe.
Thanks. Next up, Keith. Keith, are you there?
Sorry, I only clicked the raised hand button. I was going to say we're probably all going to mirror each other, and that we say, yes, I agree with that. I agree with everything Randal just said. The thing that I always try to keep my eye on is where reality, in terms of sort of the timeline of unfolding sort of development technologies, is likely to actually fall the most likely. We tell a lot of science fiction stories that are probably unrealistic, not because they're technically infeasible, but because they're a very unlikely unfolding of historical events going forward. So are we really going to have full brain emulate? This is exactly what Randall just said. Are we going to have full brain emulations up and running in a world in which the economy still works like this? I find that somewhat inconceivable, because I just think it's far enough out in the future that the way in which we get work done will have been transformed to no small degree by the sort of development of AI, of neural nets of this sort, is going to move work to such a new place that by the time we're emulating brains, I just don't think it's even relevant whether we're going to apply EMs to just sort of, go pick rice in the field. It just doesn't matter. I think that was my main point. It's just, always keep your eye on where you think that the likely timeline is actually going to go, because otherwise you're just philosophizing about something that's never going to matter.
Thank you. Florian?
Thank you very much. Yeah, I agree with everything that has been said, and these are very interesting points to discuss. So one other thing that I'd like to throw in and think about is, no matter if it's a whole brain emulation per se, or if it's some other form of artificial general intelligence, even if we think about the idea of enhancing humans in a way that at some point their intelligence might be something that is completely incomprehensible to us biological humans. So I think one question to ask is about the evolution of these digital beings. So with unlimited, or basically unlimited, computational power, information processing and storage, and also research and new technologies could potentially be developed much faster. But would these digital beings consider themselves as a separate species and even care about humans? I'm not talking about the alignment problem per se, where we ask the question of whether a digital species of AGIs or brain emulated beings may replace humans, or even at some point by mistake maybe eliminate all humans. So I'm more thinking, would they even be interested in humans, and would humans in our current form, would we be interested in what these beings are interested in? So if they are so more advanced, I would rather think about us right now being interested, so from a pure research perspective, of course, in animal studies and how colonies of ants work together, but we don't disrupt them in a way. They do their thing. It's just a much different way of achieving goals and doing work, so to say. So the question I throw in, and I'd be interested to hear about that too. So if we have these very advanced beings that could learn with incredible speed, and even in a very short amount of time become something that we would not consider as an emulation of a human being or intelligence as we understand, would that even matter to us? We would still potentially pursue our own thing, so to say, our own jobs, our own work, our own goals, versus an AGI or a digital being. When we think about them doing the jobs or replacing the jobs that we currently do, may be a little narrow, because that may not even matter to them. Thank you.
Yeah, thank you. Robin?
In writing my book, I made the argument that if it's worth having 100 books on the future, it's worth having a book on a scenario that only has a 1% chance of happening. That is, so I think it's perfectly valid to discuss whole brain emulation, even if you're not very sure about how likely it is. As long as there's at least a 1% chance, then let's go for it. I think some of the responses here sort of presume that basically very soon artificial intelligence will just take over the entire economy, do everything vastly better than any, not only human could do, any emulation could do, or any descendant of an emulation could do. And that just seems to me overconfident. I think there's plausibly not only emulations could beat out AI for a while, but then descendants of emulations can have a whole, zoo of things that might compete out descendants of familiar AI in lots of possible places. At least that matters. And I think it matters who does work. I think I don't just want a future where I can be at leisure and enjoy leisurely activities. I would like part of my descendants and part of the things I care about influence to be things that work and make things happen and make key choices about how the universe goes through doing stuff and doing stuff that's valuable. So I care about how work gets done. And so I care about which kinds of things will be doing which work.
So I've been trying to raise my hand, but unfortunately Google Meet thinks that every time I speak as a moderator, that means that I already barged into the conversation. So yeah, I like Robin's point here that we have slightly different scenarios going on, and it might be useful to consider the different scenarios. So the scenario where we get the nice aligned AI systems doing all the work, fine, their brain emulation is going to be about the virtual leisure for those who decide to go post-human. We have a Robin scenario where AGI doesn't arrive first. It might be happening very soon after. It's interesting also to think about what is the really unique property about brains here. So Robin had a good argument a long while ago about where brain-like systems actually fit into an economy. There are many non-brain-like systems that are economically very productive, and I guess this actually goes back to old conversation about the nature of a firm. If you think about Koene's and especially Herbert Simon's work, it turns out that organizations with kind of internal planning embedded in a market, the balance between them depends a fair bit about economies of scale and transaction costs. And if you change that, they might shift around quite a bit with distribution-wise. The thing I originally wanted to say, and I just want to sneak it in here before returning to my quiet moderator role, is that the unique thing about developing cognitive enhancement for brain emulation is that there is an undo button. You can actually try out something. If it's good, you say, okay, I'm committing it. I'm going to be using this. If you don't like it, or if people standing around saying, that Anders didn't turn out very well at all, you can revert to backup. And indeed, you can do this, of course, in all sorts of interesting parallel forms. That raises several interesting issues, both the practicalities of doing it, but also pre-commitment. Right now, I might be totally fine to sign myself up for running 1,000 different iterations of my brain being optimized. Being one of those iterations, however, might make me say, no, stop this. I hate this. I don't want to be in this situation. So there is an interesting question how much you can commit to. Informed consent, in this case, becomes an interesting issue. And this might actually be an early case where we might want to start the thinking, because this goes to issues of self-experimentation. And indeed, that is going to be relevant for volunteers for brain emulation once it gets to the human stage. What can you volunteer for? But yeah, I've talked enough. I should shut up and hand it over to Keith.
Let's see. So we've racked up a bunch of little things I just wanted to quickly respond to. First of all, I think Robin asked whether I thought there was only a very small chance of WEBE occurring. No, I think it's essentially inevitable. I was asking whether or not by the time we were able to do this at the scale of the human brain, which I think is pretty far out, the sort of economy in which it would emerge would be comparable to today's work, sort of way we manage work. That's the only question I was asking. I wasn't asking whether there's only a small chance of producing whole brain emulations. I think it's essentially an inevitability. There was also an interesting point about whether they're going to have sort of this runaway effect and sort of be bored, sort of the moment we're able to produce whole brain emulations, will they, within 2 days have advanced to the point that they're basically bored of humanity and there will be this sort of massive disconnect. Bear in mind that over the next, I guess I don't want to put a number on it, but I'll just throw a round number out just for discussion. Over the next 100 years or so, that it takes us to get to the point where we can actually do this to a human brain. Maybe it'll be 1,000. I don't know how long it'll be. We will be making other advancements sort of along a parallel track. Most crucially, the integration of our computing tools into the biological brain in the form of just sort of plug in prosthetics or whatever other sorts of incorporations and augmentations we had. It's entirely possible that by the time we can just whole parcel scan a brain and just take a brain and make an upload, by the time we can do that, we may almost have developed a technology to take somebody's brain, sort of take somebody's body, their life, and just prosthetically augment it to the point that it is tantamount to a whole brain emulation. And it won't even matter which of these two paths any one individual follows, but you don't have the society in which, oh, well, here's a whole brain emulation and here's a person. And we've got this like fundamental divide between them and a fundamental decision to make about how to interpret them. It's possible. That's just not what's going to happen, sort of in the way that I just laid out. I'll leave it at that for a moment.
Thanks. Randal?
Yeah, my main point right now is just that we have now spoken about this for 15 minutes. We don't have to stick to any kind of time limit. I just wanted to let you know, Anders.
Yep.
And then my other point that is more relevant is I feel like very often we're talking about almost as if we're trying to figure out what might happen or what is going to happen. There's nothing wrong with that, of course. But I'm not hearing, or maybe I am hearing some, but not that much discussion of what would we like to see happen and should we do something to make it happen. And I'm hearing this in the context of a number of things that might be considered ethically questionable. Like, for example, Anders gave the example of, say, running a whole bunch of different emulations of yourself to test out various different possibilities, which sounds great at the surface, and we kind of want to take advantage of that, but it sort of also says, oh, you can, you have to start asking questions about where you draw that line, the one that Timothy was talking about before, like where is that a new person? Is it the same person, extension of that person, and so forth? Because can you sign someone else up for, an experiment if that is a different person, right? So there are all these, I feel like there's this problem where we're doing these things not just for the heck of it. It's not because, oh, whole brain emulation is going to happen, and so therefore we need to figure out what's going to happen when that happens. No, there are people here actually physically working on whole brain emulation, making it happen. So there's a reason why we want to do it. If we're working on something to make it happen, then we probably have some responsibility to want to see that the future is a good future and to drive in that direction. But then if some of the things that we imagine are possible, like what Anders was saying, which sound fantastic, but there are ethical quandaries such as, is this a different person you're signing up for an experiment? Then we somehow have to at least come to a consensus about that, or at least explore the possibilities of how to decide whether or not it's a problem. And I'm not sure exactly how to track this. And I guess this goes back to the whole reason why this panel is here, which is we're hoping to start writing up some sort of thoughts about a framework of ethics for this. And this would be a framework that would apply to, say, patients undergoing whole brain emulation, their situation before, during the procedure, and after. It would apply to researchers working on it and even working with animals and early experiments and everything, going through that process. And then also, of course, society as it is now, society as it is afterwards, and how that is. So, yeah, trying to get a handle on that. And anything you guys could say that would help us figure out how to think about that. Yeah, wonderful.
That's a great summary. I'm happy to run this discussion a little bit longer before shifting, although I think we need to shift because we have many other points eventually, and we're also going to have some breaks. But I like trying to finish each of these sections insofar it's possible with thinking, could we do something here that is likely useful? So the most obvious thing here is handling pre-commitments of various kinds. That already shows up, of course, in issues of patients having living wills. So we might see similar things about volunteers for brain emulation. But it might also be that once we get to the point where we have brain emulations, we might want to have really reached a good consensus on how would we run these experiments. And I think, a pre-living will, that's a great point, Henrik. We want to kind of come up with a way of doing this commitment, and they can sometimes get really weird, especially once we get to branching identities. After all, if I if I make a promise and then I make 2 copies, are both copies bound by that earlier promise? If I'm married to somebody, does that mean that both my copies are married to that person or not? But also, perhaps more importantly, if I decide, okay, I'm going to run this experiment, and then after that branch gets deleted, that branch might change its mind rather quickly, perhaps, or not. But how much I can pre-commit on that? I think making a system for allowing this to happen, first maybe in the research community, for thinking through things. And this might also apply a little bit to what we get in the animal rights ethics, perhaps early on. I think we should need to think about how do we move towards getting something like that, because that's presumably then later going to become more of a praxis out in society when brain emulations, if they become part of society, which is a rather important issue, they need to have a legal and ethical system compatible with being part of society. Okay, do we have any more things somebody will want to bring up here? Now is the chance. Okay, Robin.
So I was saying in the concept, the relevant concept here is contract. A person makes an agreement, so you can make an open-end agreement, i.e. anybody who satisfies the following conditions, and I pre-commit to agree to the following relationship. And so then the real question might be, do you want to constrain the range of contracts? And one plausible condition you might want to have is, say, against slavery. We do, at least today, limit agreement to slavery. So then you might want to insist that this new scanned uploaded creature has some self-autonomy choices and ask what the constraints there might be. But otherwise, once you make the minimal constraints on contract here that we would make on any contract, then the simple thing would be to let people make agreements and enforce them.
So just to respond to that, because one of the interesting things is the concept of being a legal subject. This is quite often misunderstood, but basically a legal subject is an entity that can make contracts, and that includes natural persons, but also various organizations and corporations. And the interesting part here is not so much when people start arguing about whether corporations are people, but actually you can make nuances here on what kind of contracts different kinds of entities can make. And this is an area where I would assume that one can actually get a legal community and the ethicists actually developing various shapes for how that might work for various forms of entities, including brain emulations. It seems like this is an area where we might actually want to do some work long in advance. So once you get to the brain emulations, we actually can see ways of making that kind of contract and have them work as legal subjects. Even if they're not legal subjects, there might still be moral subjects that we might as a community say, yeah, we haven't convinced the politicians that we count yet. However, we are going to endorse that these kind of contracts have at least a moral force. Okay, Robin wanted to respond.
Just to add, those of us who are cryonics customers might now want to contract with our cryonics providers, etc., for how we might eventually be emulated and the conditions for that. So this isn't a future hypothetical for some of us.
It might actually be a nice thing to put on the to-do list, that maybe we should write a paper together with some lawyer about how that actually ought to work. That might be a useful seed for developing this idea further. Anybody else want to get in on it, or should we jump down to the existential risk issue? Sounds like everybody's totally eager for existential risk. Okay. So the next issue is brain emulation obviously has a link to existential risk. And it's interesting that it seems that it can be both a positive and negative factor. You can make an argument that there is a fair risk of getting race dynamics, and brain emulations might have powerful economic or military intelligence advantages. I argued with Peter Eckersley in our paper about risks with brain emulation, but you might also have a lot of a standard ingredients for getting conflict just by getting a new class of entities into the societal discussion. But people have fairly profound disagreements, perhaps, about whether they're actual people and actually should have rights, and etc. So that disruption might cause a fair bit of risk. Conversely, of course, you get a bigger variation of the kind of entities existing. A brain emulation is not going to be affected by the COVID virus, but power outages are way more scary, except that there are, of course, the possibility of making backup copies, except that suddenly computer viruses affecting the data center becomes significantly more scary. So it seems like here we have the issue, the ethical issue of how do we ensure that we get the most existential risk ethics related good out of this. Anybody wants to start on this? Randall?
So I'm not sure if it's necessary, but we haven't had Mirinda read out this particular one, just letting you know that.
I did my own riff on it. Sorry,
I found your intro here very interesting because, I mean, you kind of went in another different direction than this particular example of existential risk, but it sort of points out that we're talking about, say, there's the existential risk that whole brain emulations might pose to what we consider the current population of humanity. There's the existential risk to emulated persons, as you were discussing with viruses and so forth. And then, of course, there's the question of what is the contribution, positive or negative, of whole brain emulations to the question of existential risk as it is currently being posed in other areas like AI, but also nuclear war and so forth, right?
Keith.
Yeah, so on the sort of most common sort of concern is whether or not these things are an existential risk to the good old-fashioned biological humans. I mean, that's not the only concern, as you just pointed out, Randall, but on that particular point, I've always, so there's two levels to this. One I actually made a moment ago, and it fits well into this conversation. Where people are concerned that sort of de novo AIs, sort of absent of an emulating sort of model, are a threat to humanity, it has often been proposed by others that the solution to that is whole brain emulation. We need to sort of bring ourselves into that space before AI sort of runs away from us. And then on the same point of whether or not then whole brain emulation itself represents some sort of new population of a different kind of people who don't have the same interests as the good old-fashioned biological people just living the good life. The point I made earlier actually touches on that. We will be incorporating prosthetic AI into our brains over the next century. And that's probably good on this very point, because by the time we could create a population of emulations that we might sort of be concerned don't have the same interests as the biological humans, the biological human population will have probably been augmented to such a degree that the question doesn't make any sense anymore. I don't know, that's just sort of a thought that I thought I'd drop in there.
So this is kind of a late arrival of brain emulation, means that many of the standard X-risk problems have played out already. So what shows up here is a different set of X-risk problems.
I mean, I was just referring to the concern that the very invention of these technologies represents a existential risk to the leftovers, which is sort of what the common, I mean, this is what people usually worry about. This is the theme of most Hollywood videos on the subject, right? So I was approaching two possible solutions to that. The WBE solves the AI risk because we become the AI. And the prosthetic sort of evolution solves the WBE risk because we become the WBEs, or we catch up with them sort of along the side path by the time they're possible in the first place. I'm sure a lot of other people have things to say.
On the other hand, you also get the problem that, well, maybe you get unaligned brain emulation in the AI case, or developing that prosthetic thing turns out to involve various risks.
Yeah, I should let people with raised hands speak, but you're right. It might even be inevitable that the very process of getting to that point, by whatever path you get there, you go through some sort of evolution and you become a different person with different priorities by the time you get to the end point, no matter what. I don't know what other people think.
Florian.
Yes, thank you. So I also, thanks Keith, I agree with what you said. And now Anders, you also brought up one point already that I wanted to mention, but so still, if it were to happen faster, so that whole brain emulation could be done earlier than expected, earlier than we humans are able to integrate, for example, with technology, our brains with technology, or that AGI happens before that. So I would also be worried, and I think we had that already before, and I mentioned it too, about the alignment problem and about the abilities. So it's really this speed at which such systems, given the computational power to their avail, could potentially learn and adapt and change. And change is, I think, the important factor, because I'm not sure if that is something to discuss today, or if we'll bring that up in the forum at some point. But are there any security or guardrails that we would want to implement, or should be implemented, even as an ethical question too? Because right now, in terms of the artificial general intelligence, not being whole brain emulation, but people seem to be very, very confident always about being able to implement some sort of a guardrail so that you cannot escape, it cannot manipulate its own objectives. But in my view, this is all very risky. So it would potentially be at some point be able to manipulate its own code, its own objective functions, and then we would potentially face an intelligence that's totally different. Goes into the point that I mentioned before, totally different than humans. So if it were to happen faster than, for example, human brain and technology integration could happen. That's a question that I cannot answer, but I want to bring it up and still discuss. I worry about this a lot. So I'd be interested to hear more thoughts on that too. Yeah.
Great, thanks. Henry?
Great. So a slightly different take on the existential risk question. You could think of whole brain emulation as an answer or a possible solution to certain kinds of exogenous X risk. So if we were facing a scenario which made the extinction of biological life on Earth look very likely, I think that is one of the situations in which you might want a plan B. And I think large language models or something like it, even if you could give them full agential capabilities, would be a very unsatisfactory plan B for humanity. Whereas whole brain emulations, if we could keep them alive, a floating data center around Titan or something like that, that becomes that's a lot more appealing. Putting this intuitively, and I think there's a really interesting metaphysical debate here about what survival of humanity entails, but we could ask, what triggers the game over screen for the human project? And I think the extinction of human consciousness would be one very good candidate answer. And I think it's likely to remain highly doubtful whether large language models are conscious. I should maybe just say quickly here that I think we're unlikely to have any decisive scientific answers to the questions of what kinds of AI system are conscious. But I think whatever your sort of credences are that a sophisticated LLM with human-like capabilities, whatever your credences are that that's conscious, your credences that a whole brain emulation of a real human is conscious should be correspondingly higher. Consequently, I think whole brain emulation could be a useful plan B if we are looking at something like the extinction of biological life on Earth. A plan B that has things in its favor that wouldn't be possessed by a plan B that relied purely on LLMs or whatever the kind of near future equivalents of that are.
Robin?
Hi, so Keith mentioned several times this idea that augmented humans would be equally capable to M's, and I just don't see that. So, we have a limitation on our mind speed in relation to our body size. That is because we are big, slow creatures to move our body parts. If our brain is much faster than our body, it will just be very frustrating to try to control the body. Whereas M's in a virtual reality could run 1,000,000 times faster with a corresponding virtual body size and controlling it, and it would feel quite natural. So I think if you've got a thing in your head that's running 1,000,000 times faster than you, it's not a collaboration exactly. I think, and you would be as modified as any M would be in some sense. I think that many people have this idea that if your descendants along any lineage could evolve without limit in terms of how much they would change, that's a disaster and must be prevented. And I honestly can't see how that will ever be prevented. I think all of your lineages, the default expectation is that they will change without limit. That's how things have been in the past. That's the process that creates these. So if you're going to argue for one lineage over another, it should be on the basis of how they will change, perhaps, and along what process. But the idea that you will limit that change to be within some bounds, I think, is pretty unlikely. They're just going to go off in all sorts of directions. And if that's disaster or apocalypse, then, your ancestors have been suffering apocalypse for a long time. Their descendants have just been evolving without limit. You do not feel much constraint to please your distant ancestors in terms of what they wanted your changes, and neither will your descendants.
Thank you. David?
So first, I'll point out, contra Robin, there are a large portion of people on Earth who specifically are enacting the things that their ancestors felt were valuable because they feel that the tradition that they have is in fact valuable. So I don't think it's entirely true that that's not a thing. But the point that I wanted to make is, I think, a little bit related to that, is people have said a number of times that if we have M's, then it removes the worry that we won't control the future. And I think that there are a lot of people who very legitimately have said, the we who controls the future shouldn't just be the people who control whichever tech it is that takes over the future. That's not actually human control in the democratic sense that we care about. And so we should be a little bit careful in saying, if it's M's, then we've solved all the problems with human control of the future, because most humans will have been disenfranchised. I will predict that Robin will reasonably say, yes, but no matter what, that we won't be in control of the future. But I do think that there is a material difference between handing control of the future over to a new type of system versus future humans being able to do it.
Tim?
Yeah, thanks. I think this thought is sort of related to a point that somebody already made, but it's a little bit difficult for me to think about the most serious risks that whole brain emulation poses without thinking about like what alternatives we're trying to imagine, and also without thinking about the potential upsides of whole brain emulation. So, one risk potentially, I think, as was mentioned earlier, is that human consciousness is extinguished if everyone becomes M's. Maybe there's a chance that they just won't be conscious, right? That's an existential risk, but it's hard to think about what we should do about that, because of course, if we don't have emulations, they are conscious and we can make lots and lots of them, then we're losing like a ton of upside by not doing that. So for each of these risks, I don't have a good sense of like how the potential upside and the potential downsides are kind of balancing each other out, or how they should trade off. Maybe that's because I just need to learn more about the topic.
Okay, Florian.
Thank you. I also wanted to comment on what you said before, Robin. So with being confined to our biological brain size. So in the end, if the path that I am thinking about, and many others potentially too, is doing gradual replacement of the whole brain, but that doesn't mean we're confined to the size of the brain. So in the end, the biological parts of our bodies would not matter anymore. We can at some point let them completely die off and become digital beings. It just means that we start on a biological substrate, start on the human brain, and then have the same capabilities of extension and expansion that an emulated being would have. So in that sense, I would think this limitation doesn't apply. Thank you.
Keith.
I raised my hand the moment Robin spoke, and then we went through the litany of other people, and Florian beat me by one. So I was going to make essentially that point, which is that Robin made a perfectly good point if the interpretation of what I said earlier is that sort of over the window of time that we are developing whole parcel brain emulation, the ability to actually scan and emulate an entire human brain, which is it's going to take us a very long time to get to the point where we can just sort of do that at the local, pharmacy. While the time we're developing that, we will be incorporating, increasingly invasive and powerful prosthetics into the brain. And Robin imagined that culminates at some grotesque cyborg, and that's where it ends, right around the time that we've got, whole brain emulation ready to go. But you could follow that further. What if the way that we emulate the brain is to incorporate more and more and more prosthetics to the point that by the time you can just go get your brain scanned and get it emulated, we've already done it. We're done. We've been incorporating prosthetics into our brains for 100 years, increasingly invasively. And by the time we're trying to emulate them, there's virtually nothing left to emulate, except, the newborn babies at that point. That was sort of the point. We just didn't sort of follow that all the way to its logical conclusion. Because I agree. Otherwise, I absolutely agree that if the point is that any form of sort of leftover residual biology is meant to, be able to keep up with the full-blown technological next generation, that, it's hard to find the fairness there. And I don't disagree. I think there are various ways we might, become post-biological. And again, my question is always, what's actually probably going to happen? It's fun to sort of speculate on what would happen this way or that way, and again, I don't mean to be facetious, in a Hollywood scenario, but I'm also trying to figure out, what do we think is actually going to happen over the next 100 years? And I think that some of these scenarios are not really likely, and some of them are more likely.
I think there is an interesting issue here about motivations. If you see some scenarios and say that I would like to make that one real, then you have a motivation to try to get funding and research and move the world in that direction, including convincing people that this is a great scenario. We really ought to be moving there. Conversely, there are also the scenarios that make us go, oh no, we don't want to go there. And I think existential risk is interesting because quite often that does represent scenarios that have a pretty consistent global consensus that, yep, we don't want to go extinct. We don't want endless suffering. There are some versions where you do get interesting disagreements, at least in the philosophy seminar room. But it seems like we want to avoid getting into those pathways. And that's, of course, again, where maybe early technological choices can have effect. For example, in the chat, there have been a discussion about open sourcing brain emulation technology. Maybe that is helpful or not. It's a little bit reminiscent of a debate about should we open source the various AI technologies. And there was a fair bit of subtlety going on there about it because, well, maybe we all get to run the same software as OpenAI, except that you need $1 trillion of compute to make an AI. So yeah, it's open source, but nobody can actually do it except for any $1 trillion company or state. Same thing might very well apply for many brain emulation projects. Yet once the technology is somewhat mature, that might still be quite useful, including, as I was suggesting, that in a disaster, some technologies that are only kept by a small subset of people might be easily be lost. However, a lot of spearhead technologies are also easily lost simply because the infrastructure needed to do them it can get lost. If we all had the blueprints for silicon fabs on our laptops, in the case of a big disaster, we might still not be able to sit in the ruins and build a silicon fab because that requires a supply chain that's simply enormous. But getting to that first part about motivational scenarios, it seems to me that the most easy part here to fix might be to see, can we avoid conflict situations showing up when brain emulation shows up? And that might require having brain emulation efforts to be nice, warm, fuzzy, and cuddly, so people like them. It might require having the right links to the issues of natural security or motivation. It might require demonstrating commitments to various principles of safety, both actual safety, but social safety, etc. But yeah, I've been blabbering on too long here. Robin.
So I'm 65 years old, so I've seen many decades of technological progress and people arguing over the direction of technologies. And a lesson I want to pass on that most of you probably know, but maybe just forget, which is quite often people succeeded by saying there's going to be this competition of different kinds of technologies. This is the one I would like to win. So let me go help make this happen first. And that has happened many times before, and people have succeeded at that. If you look at the range of things that might happen and you say, this is the one I don't want to happen first, and then trying to get everybody to coordinate to ban it or suppress it, that's just much harder. So I might say, if you think whole brain emulation is better than some other scenarios, the best thing to do is to probably ask how we could coordinate to push it forward faster so that it wins, rather than picking the scenarios you like least and trying to say, how can we squash them? It's just really hard to squash competitors in technology races. It's much easier to promote the winners you like.
Okay, so we should be trying to use honey instead of vinegar to get the technologies we want. Yeah, differential technology development for win. Randal.
Yes, thank you. Again, my silly timekeeper thing. So it's been 15 minutes. We can keep going on this for another 15 minutes, no problem. It's definitely a very interesting topic. I just wanted to say I find what Robin said very important just now, because when we think about existential risk and we think about whole brain emulation, very often nowadays, at least in the circles I travel in, it gets positioned as, oh, can this be our security against AI existential risk? And there I have to say, I'm not convinced. You know, I just don't know exactly how it works. But that's not the only kind of existential risk. That's one of them. And all the other ones, look at nuclear war, asteroid strikes, viruses and bacteria, and gosh knows all this other stuff. For like 99% of those, whole brain emulation looks like a pretty darn good backup, a really good way to try to make a species that can survive better further out all over the universe. You know, it's something that seems tangibly useful in all those cases. And then, yeah, okay, we can check out this AI problem too.
Yeah, so I'm suggesting that when we reach Q2, we make a little break. But up until then, let's continue. Keith.
Right. So I was going to mirror Randall's question. I'm actually going to put a link here. So I've written an article that basically makes that point that Randall just made. It just sort of it defends it almost in a theorem-like fashion. It really sort of lays out an argument that computerized intelligence of some form. I prefer the whole brain emulation approach to just sort of, you know, making AI, but computerization of whatever it is that we consider important about our society and our civilization is essentially crucial to long-term survival. There's a whole lot, it's a pretty common thread of thought. It basically comes down to facilitating getting the heck off the planet, and then originally out of the solar system as well. And, you know, it's the, you know, the further you spread, I mean, physically spread, geographically spread, then the greater the opportunities to survive local calamities. So that's, you know, I was just going to say that the point has been made before. Randall made it again, and I've actually written in detail. And as a commenter is pointing out, other people have written it as well. So, yeah.
Yeah, I think it's interesting that the X-risk motivation for doing brain emulation, at least from my long-termist perspective, seems to be a really powerful, really good motivator, except that I doubt that's going to appeal to that many people. But it's one good motivator. It's kind of an extra plus to many. I think to the others, they would say, yeah, but brain emulations are weird. So that is a negative future. I might not want that. But I think that's a much more quieter concern. Now, I think we might actually want to take a 10-minute break about now. I think this is a good kind of knee point in our conversation, because many of us probably need to top up our caffeine and similar things. Or whether that is evening coffee or morning coffee, depends on where you are. So I suggest that we meet back here in about 10 minutes. Does that sound good? Great.
Excellent. Thank you.
Cheers.
Excellent. Are we switching to another topic? Is that what we're doing?
I think so. I think it makes sense to move on to neurosecurity. I think we got some good ideas there, but it's useful to keep on moving between the topics. Okay, so should I intro this, or well, I guess that's the simplest thing.
We could have
So-
Mirinda read this one, and then you could add to it however you want to.
Yeah, whatever works best. Should I go ahead and read it? Okay. So the topic is on neurosecurity and mental privacy. Once uploaded into a digital format, individuals subject to some background noise. Okay. So once uploaded into a digital format, individuals' consciousnesses could be subject to surveillance, monitoring, or control by external entities. This raises concerns about privacy, invasion, manipulation, and the potential for individuals to be coerced or influenced without their consent. Governments, large corporations, or malicious actors could exploit digital consciousnesses for various purposes, including behavioral manipulation or intelligence gathering. Corporations could abuse our mental privacy by hacking into the computers hosting our emulations or using our mental data for corporate gain. Moreover, without reliable security measures, unauthorized alterations could occur within an emulation's digital consciousnesses, resulting in individuals losing trust in the integrity of their own mind and personal experiences. So the question to the panel would be, can you suggest policy making, planning, and initiatives to implement in order to protect the privacy and security of emulated minds and to avoid personal security risks posed by whole brain emulation? Is it theoretically possible to develop a firewall strong enough to safeguard the mind and its data for beings existing in digital form?
Cool. Thank you so much. Yeah, so on that last line, in that paper I alluded to a bit earlier that I wrote with Peter Eckersley, we were, of course, very much thinking about privacy, and we looked briefly into the idea of homeomorphic computing. In principle, if that worked well enough, you could imagine having an encrypted version of a brain emulation running on a data center that you wouldn't trust, but that encrypted computation would be able to at least be safe from somebody reaching in and trying to hack them. Unfortunately, that still doesn't stop from copying, for example. So you might still have a serious problem about getting pirated, which might be way worse if it's people that you're pirating rather than software or movies. But anybody wants to start on this mental privacy issue? Keith?
Well, let me see. I'm not sure if I actually understood your point, because if it's encrypted, then if you make a copy of it, doesn't it remain encrypted? What were you implying?
Well, you could still perhaps run the encrypted version. You don't get to see the internal states, what is it thinking, but it's still running.
You can't look inside, but you can't actually prevent them from existing. Someone can sort of force you to exist.
Yeah.
You know, an interesting thought there. This sort of gets into what sort of mental powers we can give these things, but can they basically have sort of cognitive control over not only their encryption, but essentially sort of whether or not they exist? Although that's a little, once you sort of duplicated someone and forced them to exist, it's the cow's out of the barn at that point. That's a good point.
Yeah, That is a really cool, also technical question. So Peter and me speculated, I think in a footnote in that paper, it was years ago, that you could at least put in a computer program encoded as a neural network and hide it inside the bulk of a brain emulation. So that would suggest that you could put in malware. And that has been later demonstrated in LLMs and other neural networks that you can do. But you could imagine using this also as the virtual suicide pill. You could imagine that actually there is a program that is embedded in the neural network in such a way that it's actually very hard to separate from the actual neural network, and could be reading mental states, and if you develop the right mental state, it might activate some other code inside that system, which might turn off the emulation or make you unconscious or something. I'm not certain how well I would trust that thing, but there might be some very cool things going. But anyway, I shouldn't be blabbering on. Tim?
Yeah, thanks. Someone who doesn't know a lot about the technical side of this, I'm looking for the ethical questions here. So I guess, is it theoretically possible to develop a firewall? That's more of a technical question. But on the policy making and planning initiative side, I guess I'm wondering what the question might be presupposing. So, we already have, laws to protect people's privacy. Those laws are different in the EU than they are in the United States. I guess, so what are the sort of special considerations that might prevent us from just extending those laws to cover the case of whole brain emulation? I guess one difference is that intuitively the stakes are a lot higher. I guess if the stakes are a lot higher, you could do things like, make the laws stricter, or, impose, the stricter punishments for breaking them. But are there any other kind of special considerations that make this kind of case different from the case of privacy security that we already have, apart from the stakes? Is it like would it be easier to to hack into computers hosting emulations than it is to, hack into a database and steal your health information or your credit card information or whatever? Anyway, that's just a question from the naive panelist here.
Well, I think it's a good one, because sometimes technical aspects matter a lot. For example, a brain emulation is probably going to be a fairly bulky piece of data. So I would guesstimate that it maybe a few terabytes in size, which might mean that it's non-trivial, at least at present, to sneakily move it out of a system. But that might, of course, change given how much bloatware we're getting in our computers anywhere. Similarly, you have an interesting issue that copying can happen without anybody noticing, assuming you can exfiltrate. But the ethical ones are interesting, especially since another way of getting compliance is not to make punishment harder, because that has surprisingly little effect. But enforcement, if you know that you're going to get caught, that actually reduces crime quite a lot. The problem here might be that enforcement might be really tricky. But it's Robin's turn now. Sorry.
So I have an old friend, Mark Miller, who specializes in secure operating systems. And he tells me that for computer security, it is not a technology problem, nor is it a legal problem. It's a business development problem. That is typically because most operating systems aren't secure and most system environments aren't very secure, that the fastest way to get a product to market is typically to ignore security, and that usually it's hard to tack on security after you've made an implementation that ignored it. And that's the main problem why most computer systems are insecure in our world. And I mean, some people, I guess, are worried about people too easily agreeing to give up their privacy in social media, et cetera. But I think they mostly know what they're doing and they want to do it. And so I'm okay with it. But I think the question here more is, if whole brain emulations also happen through a technology race where it's a premium on getting to market first, then they might also neglect security in the design of their initial systems. And that might be hard to tack on later. So that's where I would focus on thinking about how could we create the context or incentives of development to pay more attention to security here than is the usual case.
Henrik?
I have a couple of thoughts about this. To start with the latest thought, whole brain emulations on the original biological substrate is not very secure at all. And you can hack people as they are now quite, it's not very difficult to actually hack people. And if you digitalize their conscious and get an infinite amount of try-overs by backing up to the original copy, you would basically be able to hack anyone, because we don't have any firewalls worth anything in our brains as they are now. So that must be retrofitted. As Robin said, that's difficult to do because first the market in the brain market didn't care about mental security. And we have no firewalls worth the name. And therefore, we have all the problems with Trump and sects and Putin and stuff. And if continuing on that, if you have a copy of someone, you can do statistically correct torture. Run 100 parallel instances, ask them the same questions, maybe torture them a little bit and see what they answer. And if you introduce a variant in the torture or the questioning, you will not necessarily get the same answers. And you can get a statistic idea of how the person would think or have done something that you want to ask them about. And lastly, if the copy is regarded as being alive, you could be maybe sentenced to be a copy. And then the court would interrogate you. And you can't do very much about it because the digital you is still alive, even if the biological substrate is ditched. Rather dystopian maybe, but that's the thinking that I was doing while listening to you.
Thanks. Florian?
Thank you. I think all very good points. So I will comment on the more technical side of things. As you probably heard and know, the most prominent threat right now to any encryption, to any system that should hold data that's to be secured, is the quantum computer. We're not there yet where you can crack all network-based communication, but most of the algorithms, most of the things that we use for both data in motion and at rest rely on algorithms that can be, or encryption algorithms that can be efficiently, more or less, cracked by quantum computers of sufficient power. So what that sufficient power is always a question. But then the prevention of how we can still secure system also lies in quantum physics. And that raises interesting questions. So I would agree that we would probably, or should probably, try to give the emulated being the ability to be in control of encryption for its own systems, for its own data, for its own whole emulation. And as long as the quantum theory doesn't break, then you would be secure. So it would even be impossible to steal some information or monitor communication without the system noticing. So without anyone noticing who implements one of these quantum secure communication protocols. So that is an interesting thing. So even if no harm is done, even if someone makes an attempt, we can already see. So that would be a way of preventing that. Now, thinking further, I mentioned at the beginning, I think it's mostly physicists who come in and try to understand on a physics level instead on a less granular level what happens. The other question is, so should quantum effects play a role in the brain? Then there is something that is called no cloning theorem. So it would even be impossible to copy an emulated being that uses quantum effects for processing information, because it would inherently destroy the computation. So the physics doesn't allow it. There's more to say about it. I just wanted to bring it up. So that's an interesting question, Lou, if that were to be true at some point, or even if we were to use quantum computers to run such systems, which seems reasonable. So even if these effects currently in our classical brains don't play a role, then there may be challenges for an attacker that would prevent such an extraction of information, or at least things that we can do about it.
Randall?
Thank you. Yeah, that's super interesting. I'm actually very interested, if we have time and if, say, there's another topic to talk about that, to talk a bit more about quantum mechanics and all of its potential involvements. We can also do this after this event, of course, Florian. I know you're very interested in it, so that'd be great. I want to add maybe like this kind of crossover here between technical requirements for whole brain emulation to be possible and security, because we sometimes think about this as, oh, this is a program and we can use whatever methods we can have to our that we have available to secure it, and maybe we can use quantum encryption and whatever. But it's very likely that you have to give access to a lot of what is going on in your mind, at least during the verification and validation phase after you've had a whole brain emulation. Because you know how it is when you build models, they never work the first time. There are always problems and errors. So someone's going to have to fix those. Someone's going to have to check that everything is okay. So you need to trust someone to do that. So there's an issue here of having to deliver yourself into those hands, at least to some degree. And then there's a likelihood that you may choose to do so later on. Robin already alluded to that. People may sign away their privacy and their security. And there's a strong incentive to do so after uploading, because one of the reasons to do it is because you want to enhance and augment and go further. And if you want to be able to do those things, you also need access to the brain. You need interfaces to what's going on in your mind. You even need to be able to change things that are in your brain. So you're probably going to give someone permission to do that. So yes, this is partly a technical question, but it is also a non-technical ethical question, as in, where do you draw lines there? What do you have to watch out for? How can you safeguard persons even when they have to give some access to what is most dear to them, about as dear as your DNA is, even more so probably. So I just wanted to put that out there, that it's very likely that no matter whether you're using quantum encryption or whatever else, that at some stages you need to give access to your mind. Oh, and that is just the 15-minute marker.
Oh, yeah. It looks like we want to go on a bit more, but the interesting thing here is, I think you're totally right, Randall, that we sometimes need to give access, and definitely when creating the brain emulation. And I think that's very similar to the situation when we end up at hospital. So if I'm getting into the surgery and Henrik is showing up with the anesthesia, I better trust him and the surgeons and the team a lot. And normally we do that because we have an institutional framework that is intended to ensure that we can trust doctors a lot. There is some parts of that institutional framework that are legal aspects. A lot of them are kind of inculturating an ethics and professionalism. But we can think about trying to build something similar. Presumably, I don't know whether we want a Hippocratic oath of uploaders, but you probably want something like that be in place before you really start doing. You want to really show that, yeah, here we have a system that recognizes important aspects of neurosecurity and mental privacy that you can actually trust with, well, yourself and all your future selves. That might also be an interesting thing to develop into the detail. Yeah, I love the idea of carbon copy certified organizations. Now we just need to figure out how to actually do that certification. Do we have anybody suggesting how to do this in practice?
Well, I mean, just to come back to Randall's point and the point that you made, you know, even contemporarily, while software is in a state of development, the people who are writing it have, full view into their own product, but then when it is unleashed on the public, it is, unleashed in a much more secure fashion. I don't find anything particularly contentious about the fact that while you're, getting your brain uploaded, that is done in a secure environment with an entrusted entity that does the job properly. But then what they hand you is this locked down product. Once you've done all the validation and it's good emulation, well, here you go. But now it's wrapped in ironclad, security.
Yeah, Randall?
Yeah, no, I agree with Keith that, I mean, typically, and of course your comments as well before, that you do trust your surgeon and stuff like that. And the same way you'd want to trust the organization that is doing your upload. It just reminds me of something that we were worried about back when we were trying to think about doing new probes at kernel and them being really high data bandwidth probes to collect a large amount of what's going on in a certain area of the brain. One of the things that came up is that this very first stage of the process, where you're still working with the analog signal, is one that is typically not well secured at all. You could have someone sitting even at a mild distance and picking up signals from that and recording them. So, this gets into espionage and all sorts of other things, and like trying to copy the brains of important people or whatever. You can come up with a wonderful thriller about it, pretty much. But these are also some issues to consider that are perhaps not as important at this moment compared with the bigger just issue of of security of your mind just overall.
Yeah, Robin was reminding us that we need to think about stuff that might be useful to work out beforehand. So it seems like there is this interesting issue. Do we need a few ethical failures of brain emulation before everybody starts using the professional rules? And I think that is a likely situation to happen, but it might be a good idea to try to figure out what should be in place to make it less likely that that happens early, so it actually breaks the technology. I think many emerging technologies go through a very vulnerable state where they're seen as optional by society, and if there is a problem, you might shy away from them for a long time. Gene therapy, for example, had that situation. The Zeppelins ran into that. While on the other hand, one of the first steam engine trains ran over a member of parliament, and everybody agreed that was terrible. Let's not do that again. And then it had enough impetus in society to be doable. So it might be that we want to figure out what parts do we want to set up beforehand. Also because we probably want volunteers to volunteer. And we don't want the crazy volunteers, as Henrik pointed out. You don't want the people who are just saying, oh, upload me no matter what. They're probably too crazy to be good first volunteers. Okay, do we have any more points on this, or should we go on to the next topic? Okay, so let's see. So now it's access and inequality. Oh, that's a big paragraph. Yeah.
Are you okay to read it, Mirinda? You're muted, by the way.
Okay, so access and inequality, the democratization of whole brain emulation. So whole brain emulation technology has the potential to provide immense financial and social advantages to those who have access to it, potentially worsening existing socioeconomic inequities. Developing countries may struggle to afford or implement whole brain emulation technology, further widening the gap between the developed and developing world and catalyzing global inequalities. Emulations will have the capacity for rapid learning, data collection and processing, and enhanced problem solving, surpassing the cognitive abilities, resources, and work productivity of non-emulated individuals. If only the wealthiest members of society can afford to have their minds uploaded, this technology could create exceptional socioeconomic advantages for the wealthy, leaving the lower and middle classes behind. Can you speak to the affordability and availability of the whole brain of whole brain emulation technology? What are the costs associated with mind uploading, and will the price be affordable and services be available for all? In your opinion, what are some of the most important policymaking efforts that carbon copies can work on today to ensure democratization of whole brain emulation and that everyone has equal access to this technology?
Cool, thanks. Okay, any takers? Robin first.
So as an economist, I have to point out that our default in society is basically to do nothing about new technologies and the inequality they might produce. We have generic ways society tries to handle and deal with inequality, such as welfare, things like that. But otherwise, and insurance is one of our main technologies for dealing with inequality. Sometimes we include social insurance. And so I would say, the obvious thing to do here is to at least set up the right sorts of insurance to limit the kinds of inequality that insurance can here, and that would be quite feasible and quite valuable. As I said, in part, there's the insurance against just losing your jobs to M's or AIs. But again, notice that our default in general, across the world, across technologies, is to mostly do nothing about inequalities produced by technologies, and I'd say that's usually roughly right.
So this discussion also mirrors a little bit what I often heard in the early days of enhancement debate. Again, the standard thing was, these cognitive enhancements are really going to help the upper classes be very effective in upper class, and that's bad. So that might be a reason against having cognitive enhancement technology. And it seems to be a very generic argument, and it's of course also based on an assumption that actually it works like that. When we started poking at it, immediately starts turning in kind of tricky. It turns out that enhancement might be good for having a competitive advantage, but then there might be a good reason to subsidize it for everybody, etc. There are network effects and so on. So in some sense, it might just be that this is a far mode thinking. People think about a weird new technology and then project a standard, very general concern. Inequality is bad. Hence, this technology might affect inequality, which might be seen as, that is a reason against the technology, or as a reason to try to do something to fix the technology beforehand, which I think is more of a context here from carbon copies. Now, I think I added a side note here that, in fact, many forms of inequality might go really weird. As I had a scenario based on Robin's book where, maybe rich people upload themselves. And now you've got rich people forming copy plates. So their wealth gets distributed across a lot of copies. And actually, now we're very egalitarian internally, but maybe having even more power or wealth compared to the rest of society. That takes the inequality into such a weird direction that I think most of the standard inequality talk just breaks down. And people get annoyed at you because you're not following the rules for how they think one should be talking about inequality. I do think there is something interesting, because one of the most extreme inequality that does show up in the age of M is the fact that it might start out with very few very copied brain emulations. They might not be wealthy and important people from the start, but Mr. Lee, the very pliant lawyer who is totally fine with having millions of very adequate lawyer copies around, he starts becoming a major demographic and dominates the legal business. Suddenly, that's an enormous inequality. Movies that sell very well to Mr. Lee's copies are going to do very well indeed, etc. So you have an inequality, but it's not of the same kind. So I wonder what one wants to do here about that kind of new or weird inequalities. But anyway, Tim.
Yeah, thanks. So just first an observation. So the question or the description here, in the description, the concern is socioeconomic inequality. But in the later part of the paragraph, it seems to suggest that the inequality that we should care about is inequality in who has access to the technology. And those two things presumably can come apart, and we can ask which one we care about, right? So one of the ideas that Robin talks about in his book is that even those who don't participate in, the M society by being uploaded can still be investors, right? And they can potentially benefit from work that's being done by M's. There might still be, inequality in that case, but it might be the sort of inequality that, lifts everybody. And of course, there's a debate in ethics about whether we should care about that sort of inequality. If the gap between the haves and the have-nots gets bigger, but everyone has more, maybe that's something to worry about. Maybe not. The other thing I'll mention, and this is related to a bit to Anders' point, is so Anders mentioned rich people being uploaded and their wealth being distributed across many of their copies, so that you have something like egalitarianism among uploads, but maybe an inequality between uploads and non-uploads. It's interesting to think about how on some ways of measuring inequality, like if you take the Gini coefficient, for example, if you had a society where most of the people who were, had the wealth distributed equally amongst them were M's, and they outnumbered vastly the people who were non-M's, who had much less, that would actually come out as a pretty egalitarian outcome. Right? The Gini treats unequal situations as having more inequality when those who have a lot are sort of few in comparison with those who don't have much. So that's just to say, I agree with the thought that we should think more carefully here about what measures do we want to adopt for inequality, and what is the inequality of what question comes up here.
Great. Randal?
Yeah, I want to go at this in a slightly different way, because it seems like we're talking about mostly giving people access and equality in that sense of here are all the people and how do we spread out, which I think is important, but it's important, in my opinion, not just for the reasons we might be thinking about. And just to give an example of how extreme it can be, like we had the example of like this one person being copied 1 million times, but we could also have, say, a single whole brain emulation turning out to be so powerful and so fast that it's kind of like the single AGI concepts, that kind of becomes the god. So we can imagine a situation like that. But here's the big problem. Even if we just have, say, 1,000 wealthy people uploaded, and then the rest of the world gets happy because we get a lot of resources and whatever because they're so good, I worry about the risk of monocultures. I worry that not every mind, not every way of seeing things, every perspective is necessarily the right thing for every future outcome, and that we get a lot from, say, what nature has come up with, this sort of, oh yes, we have to have gendered ways of procreating because then we mix up our DNA more, and that leads to like a healthier overall population. And in the same way, if you have too few minds being uploaded, I worry that this is not going to represent enough different ways of thinking necessarily. Now, it may not be the problem. You might find other solutions for that. But I do worry about that aspect of it. Like, I think there is a good reason to want to strive towards, and not necessarily equality, but a large opportunity to distribute this availability to join in, say, a society that has uploads, because then you don't end up with a monoculture or something approaching a monoculture.
Okay, Henry.
You are muted.
Sorry, I was on mute. I was going to say, at the risk of sounding a bit repetitive, I think probably the next 5 or 6 years are likely to be incredibly economically and socially disruptive, not due to whole brain emulations, but just due to the rollout of AI and a bunch of other domains. And I think it's going to force us to ask difficult questions about the economic viability of people in a lot of white-collar jobs, for example. And I see a lot of really difficult societal and economic questions as being sort of upstream of the point where we get whole brain emulation. So I would think that it's possibly premature to start building out detailed strategies for improving access to whole brain emulation, given that, yeah, access to that is going to be a consequence of the societal conditions we find ourselves in 5 or 6 years from now. Obviously, that doesn't mean it's not worth doing scenario scoping and scenario building to sort of think how we could handle this. But yeah, I expect the world 7 or 8 years from now to be already very different from the world today. And those are the kind of timelines I roughly see for whole brain emulation becoming viable at a large scale.
Okay, Robin?
Some of us don't expect that much change in the next 7 years, of course. I wanted to, repeat and emphasize the point that Anders made and others that, evolutionarily, you might think the kind of inequality we would most be concerned about is inequality in lineages, like who has the most great-grandchildren. But surprisingly, in our society, when we focus on inequality, we don't seem to care much about that. We care more about sort of per year consumption, and we don't even seem to care that much about some people living longer than others. So if we project that kind of inequality onto the M world, it's a pretty egalitarian world. But of course, in terms of lineages, it could be very unequal. Surprisingly, people don't seem to care so much about that. On Randall's point about having too many, too little variety, I think the main cause there would be something like academic mutual admiration societies. There are many ways in which sort of, cabals of people limit the participation to insiders and then push out outsiders. And that would be the kind of process I might imagine would limit too much variety. But if we have just full, strong economic competition, I'm pretty sure that will, give the right marginal value to variety, because if you, on the margin, if you're a little different, then if that means you get to avoid all the groupthink that everybody else has, then you can have the advantage. So often, for example, corporations definitely fire their leaders when they're too old to be productive. They don't just hold them on until they die, like some other processes we have in their familiar world. And so if we have sort of strong economic competition, I'm much less worried about the having too little variety point, but there are other kinds of social processes that do often create an insiders club that limits variety.
Yeah, so it's an interesting thing what kind of inequalities we would accept here. It seems like what happens happens, but we might want to set up things to make things more acceptable. And this goes back to that open source question before. I would assume that a world where brain emulation looks like it's feasible. Many people say, I would actually like to be a brain emulation. A lot of other people say, absolutely not, that's nuts. But showing that might be an open option might actually have quite an importance. So this gets to the question, can the technology be open source so one can show that, yeah, this is eventually, at least after the first ridiculously expensive ones, are we going to be able to show that it's plausible that we move in that direction? That might have a big effect on people's view about how unequal it is. But then you have founder effects, and I actually do think that as we're joking here in the chat, that yeah, it's fairly plausible that the first few are going to be pretty extreme outliers in a lot of personality traits and skills, which might then create also a society online. When the second generation shows up, they might be uploading a week after, but by that point, of course, the founders have already gone off and built their libertarian utopia, etc., whatever. So there is I think it's an interesting thing, because this again goes to what do we actually desperately want to avoid. I think something might be that, okay, there is a monopoly on access to brain emulation. that seems to be something we might want to really avoid. We might want to avoid that, okay, there's a very strong winner-take-all situation among the copies or the other technologies, because that might cause too much instability. So we might want to moderate that beforehand. Is there anything else that we could set up here beforehand that would be useful? Or we could move to the next topic, of course, if we think we have kind of exhausted this one. Randall?
Yeah, I don't have so much to add except to say that I really love the question. What else can we think of in advance to try to avoid or to strive towards? But it is, I'm finding it hard to think about it and come up with something. So yeah, we might have to move on. But I really like the idea of talking more about that.
I think in general, we should probably treat this discussion as we are seeding some intellectual inquiries and research projects to work on, rather than saying that, oh, we have totally have to resolve this. But yeah, let's move on to the research and development with animals.
Okay, so research and development with animals, both biological and digital. These are research animals. So researchers learn how to carry out human whole brain emulation and uploading by testing methods with various animals such as rats or non-human primates. What must researchers do to prevent suffering of not just the biological animals, but also suffering of uploaded animals? Is it as simple as providing digital painkillers to the digital animals when running experiments on them to ensure they cannot feel any pain when we are experimenting on them? That is commenting out the lines of code generating the pain system in the digital animal. Presumably, hundreds of thousands of digital animals will be created in the process of developing human digital consciousness. What should be done with these experimental animal uploads? Would it be ethical to simply delete the data containing those animals, or should we let the animal live forever in the digital space? Or perhaps we should allow them to live digitally for around the same amount of time as is comparable to a biological animal, and provide for them a good and normal animal life before deleting them to free up computational resources.
Great, thanks. Okay, Henry is first.
So this topic is a glorious intersection of so many of my interests: animal welfare, animal consciousness, AI consciousness. Lots of things to say. Obviously, I want to quickly nod to two absolutely brilliant works of science fiction exploring these scenarios. One is Ted Chiang's Life Cycle of Software Objects. Another is the horrifying piece of short fiction, M.M. Acevedo. I'm sure very familiar to most people here. So I think there are some really dramatic ways we could go wrong in this area. I also think, for what it's worth, this is an area where I expect there to be very clear motivations for developing whole brain emulations of both humans and animals. One suggestion that I'll throw out there, which I think is seems to some people a bit of a crazy suggestion, but I think it's worth taking seriously, is the idea of hedonic offsets. So digital painkillers are one example, but I don't know, if you told me, Henry, actually, you can live another 5 years, and in those 5 years, you're going to have various negative experiences which are unavoidable, or you can choose to end your life. But I tell you what, if you agree to the 5 years of unpleasant experiences, we'll also throw in lots of great peak experiences. Obviously, I'm going to take the peak experiences. So I think this is hedonic offsets are a promising idea, not just for whole brain emulations, but more broadly about for worries about AI suffering. I guess one tricky question here, this is an area where questions of personal identity again loom large. If there is sort of a robust sense of an individual's identity or stream of consciousness that has the highs and the lows, then we can think of them as being compensated for the lows by attendant highs. On the other hand, if existing concepts of identity just don't make sense, or we're thinking about this in terms of individual experiences rather than persons or streams of experience, then hedonic offsets may not be an entirely satisfactory option. But yeah, loads more to say on this, but I'm curious what the rest of the panel have to say.
Great. Randall?
Thank you. Yeah. So first of all, I like this topic because it is so near-term relevant. This is relevant even now to anyone who's trying to take the fruit fly and trying to actually functionalize it to a working fruit fly. Maybe we don't worry as much about fruit fly suffering. Okay, maybe. But, that depends on whether you're a Buddhist or not. But certainly this is something that's right around the corner. And it's already happening in a variety of ways, of course. Now, one problem is that, again, when you're trying to build a good model of a brain and you're trying to test whether you did it right, is that you also have to test pain. You can't just not test pain. So we can't just turn all the pain off. You might even, and I'm not saying this is what's necessary, but you might even think, oh, if we want to test if a human was correctly emulated, we need to find out if they can experience a not physical, but psychological post-traumatic stress or something like that. And we have to give them that so that we can find out if their brain is reacting the right way, right? Now, here's the thing you could do. Instead of giving painkillers, you could do memory erasure. You could get rid of the memory of something unpleasant that was just tested. There are all kinds of ethical questions about that too, because this is very similar to the whole, can you torture someone and then give them a pill so that their short-term memory and their recent memory is gone, which, technically is possible because short and intermediate term memory is erasable. Of course, you also need to test long-term memory. So you need to test actual synaptic changes. So again, for your validation and verification procedure, you even have to go down that route. And so when you're talking about memory erasure, you're talking about serious long-term memory erasure if you want to get rid of that feeling of torture. Maybe it doesn't need to be at that level. You could test really small subcomponents of neural circuits instead of testing the entire thing and then just hope that it all works together. Some really technical questions here.
Thanks. Keith?
Yeah, so there are new questions that arise in this context, and Randal made one of them, which is that the whole point of creating emulations is to make sure we sort of create this new technology correctly, and that will involve testing whether or not pain works properly. Aside from that sort of issue, I wonder how far we can get on this issue by just following existing guidelines. Institutes like the NIH and all the other sort of related sort of major string holders already have very long, very thorough documents with very stringent requirements on grants and research on this exact topic. I'm just curious how far we can sort of leapfrog this whole issue by sort of following decades of work that's already been done in this space. So I'm not overly familiar with it myself. I suspect we've got a lot. We can probably jump way down the road on this issue.
Okay, I also like this topic because it links with so much stuff going on. So in my paper on brain emulation ethics, I was kind of introducing a principle, but me being an amateur philosopher, it's been done much better by Jeff Sebo in his work on animal ethics. And he's explicitly also trying to bring in this to work for digital minds. And he points out that he has a very similar principle to me, that if you're making something that looks like a system that we normally would regard as morally considerable, we should probably be very careful about it. So he calls that the precautionary tale, but you can also do a kind of expected value principle, and you can actually weave them together in a slightly sophisticated form. So I think we might actually be able to develop a little bit of an animal ethics for brain emulations in the lab before we get very close to it. And we might also want to establish that as, okay, these are the guidelines we're actually going to apply. And that might become relevant much sooner than expected, given the amazing results on getting the fruit fly to do some behaviors, even using leaky integrated fire neurons, which is frankly downright shocking that it could work at all. I just want to make that point. But Robin?
So I want to point out that our existing system that we could build on is broken. That is, standard medical ethics holds much higher standards for what you are allowed to do with patients than we accept in most of the rest of life. as illustrated, say, by not allowing challenge trials in COVID, even though we allow people to volunteer for the military or volunteer for, police actions or all sorts of things. We allow in ordinary life lots of people to take risks under uncertainty that we just don't allow in medical ethics. So I fear that if we inherit the medical ethics standards for these things, that will greatly discourage and hinder what we can do with brain emulations. So I worry this might be definitely a thing we could work on early, preventing medical ethics from being the default framing of brain emulation experiments.
Cool. Henrik?
Yeah, I agree that medical ethics is not a suitable way forward because it's so much emotions and so little thinking at the moment. So it's largely unusable as it is now. It would even only be worse with emulated brains. I would like to take up the pain aspect again, because pain is so much more than just a pain system. The loss of the sensory input could cause pain as well as sensory input. So when you say that we should give painkillers or edit out pain, it's not that easy. And we can see that even now with the original biological computer. So be very careful about pain-related problems. And NVE problem also, yes. So pain is a large problem. It will be a large problem, and the CNS affecting the CNS effects of various kinds of sensory input or lack thereof is something that will cause problems. Not necessarily ethical problems, but practical problems. But if we go for the can you kill an emulated animal, for example? Yes, if you are okay with the euthanasia of a lab animal, then you could turn off the emulation of that kind of animal too. But if we do the correct emulation of a rat, for example, then the rat will suffer. And we need to take care of that suffering in one way or another. Yeah.
Thanks. Randal?
Yeah, I think some part of what I wanted to say has already been said, which is that current laws are not super useful because it's almost impossible to do or to get any experiment through approval where someone might suffer. So that whole thing is kind of out the window. I also worry a little bit. So kind of this question's about with animals, but of course, okay, non-human primates already gets kind of to humans, and then human patients is sort of next, terminal patients who volunteer to be the first in line or whatever. And you might find that, for example, when you first try to do a whole brain emulation, that most of the emulation works. So 80% is okay, but there are all kinds of unpleasant deficits. And then there are questions about what do you do, and you could maybe ask the person, but if asking them is exactly one of those things that doesn't work, then you've got a problem. So, and maybe we can use some of the laws that exist right now about, say, coma patients and whatnot. You give someone else the right to decide what happens to that person. So there are some places I think where existing laws could work, but yeah, as mentioned, these laws on experiments and what can be done, they're not always useful, even in today's academia.
Thanks. Tim?
Yeah, thanks. Just a couple of thoughts, just listening to you guys. So one is a thought about two proposals that have been considered, the hedonic offsets and memory erasure. So it was mentioned that for hedonic offsets to make sense, there has to be sort of the right kind of relation between the animal stage that suffers and the later stage that gets the offset. And memory erasure, I don't know if memory is one of the relevant connections there, but memory erasure might sort of break that. So break that thread. So I guess in that sense, hedonic offsets and memory erasure might be, not necessarily incompatible ethically, but kind of in tension. And then the second is just a clarification or a question for the other panelists or whoever wants to answer it. So are there any, is there any research on how many of these digital animals we can expect there to be? So the description of the question says hundreds of thousands. But I don't know, naively, I thought it would have been a lot more than that, or it would have been in the millions, given that there are sort of millions of lab animals that are experimented on already. Wouldn't there be benefits from making more, more emulated animals, and so you can do the research more quickly?
Okay, Randal?
Yeah, I think that Timothy's right. There are going to be more. This number, I don't think we should take it too seriously. It's just kind of a number grabbed out of thin air. When you're working on models, you very frequently run models, and every day, lots of models, and you're running them maybe just for 5 seconds to see how they work and get your data that you need. And I can imagine the same thing would happen with models of entire animals at some point, entire brains. Yeah.
So if the number gets really, really big, then that might raise the stakes enormously, even if we're very, very confident that the animals aren't conscious, or the biological consciousness matters more, biological pain matters more than M pain, because there's just so much of it, right? So this is, I guess, where the SIBO approach that Anders mentioned, where you have to take taking uncertainty into account, it really matters.
Yeah, and it might, of course, also matter from a population ethics standpoint quite a bit. So when talking about large language models, somebody made a very important point a while ago, pointing out that if you can train a language model of a certain size, then you can also run about 100,000 copies of that model, or whatever the number was in that argument, as inference. Because training takes way more effort to do than inference. So any entity that can generate an AI can probably run many copies of the AI much better. Now, I don't think we have yet good estimates, but we probably could develop some for brain emulation, what it would take to do the emulation. A lot of that is more hardware, but some of it is going to be compute to interpret the scans in different ways. But then that might tell us something about, at the very least, a lower number of how many copies could be existing once you've done an emulation. I think in practice, you probably will end up with, well, if you have a useful piece of, let's say, a standard lab rat, that is going to show up in a lot of copies. And I can imagine so many researchers loving the idea of getting super consistent results, because we can run iterations of the same identical rat and do the same experiments millions of times over, or whatever. So that really seems to suggest that we can actually get a population explosion here. Now, Robin is next, but then we might want to think a little bit about planning because we're going to run out of time. And I guess if we're willing to go a bit over time, we should have time for talking about both the population ethics and the gradual replacement method ethics. I'm happy to be over time, but I don't know if some people might be in time zones forcing them to leave, etc. But yeah, Robin is next anyway, and then maybe we can conclude here, or at least leave it for further time.
A brief comment that might be important. Again, I think we should be looking for things we could do ahead of time that will affect how things play out later. And it occurs to me just our stance on whether we presume these things are conscious will be an early thing, because we'll actually never get any data that answers the question. And so at some point, we will just have the answer that we assume and that we go on with. And it matters which one it is. Obviously, our inclination to mistrust and even enslave M's will be much higher if we assume they're not conscious. On the one hand. On the other hand, if we by default assume they're conscious, then we'll have a lot more of these hesitancies in what kind of experiments we can do earlier on. Maybe the optimal thing is to switch right after we do the experiments. But the point is, this is another thing plausibly the field could just settle on early on, if it ever can, because basically we'll never get more data than we have now. We'll just at some point have an attitude, and maybe it matters to pick it early. That's my point.
Okay, Henry.
Just very briefly, I was going to say that I think, speaking from my position as someone who's been engaged in consciousness science, I'm increasingly pessimistic about the likelihood of having any decisive answers about range of AI systems that are likely to be conscious. I think we are making progress in animal consciousness, but it seems to me there are just so many foundational problems in the scientific search for consciousness in AI systems.
But the world has consensus on many things that researchers don't have consensus on.
Yeah, no,
researchers don't have to agree for the world to agree. That's just been a common thing. Like the world agrees democracy is great. Researchers aren't so sure about democracy being great, but the world is really sure democracy is great.
I couldn't agree more. I absolutely agree, Robin. So something I've argued in a recent paper is that the growing popularity of social AI systems, AI companion apps, is going to just shift the debate way more than anything researchers or philosophers have to say about AI consciousness, and that sort of 10, 15 years from now, the default presupposition is going to be that, of course, AI systems can be conscious. Have you met Joanna here? You know, so I think ultimately these debates are going to be settled not by a really striking new theory of consciousness, but just by shifts in public attitudes. So I completely agree.
Incidentally, this might also be very relevant for us who are somewhat professional ethicists. Many ethicists do recognize that we're pretty impotent, or rather, we're doing a lot of very fun stuff here over in the seminar room, but a lot of it will never, ever actually affect the world. And then maybe people are feeling secretly relieved about that, because quite a lot of the actual ethical change and progress is indeed a much more social thing. Sometimes there are important insights that do percolate slowly out from an academic realization, but a lot of it doesn't happen in the neat intellectually led fashion that at least the philosophers would imagine would be a good thing. Okay, so we're running out of time here. So Florian is unfortunately leaving. And Tim has mentioned that we already dealt with his the population effect. So maybe we could, in some sense, end roughly on time. Although I think it's still sad not to get deeper into these extra topics. Actually, I do think that there is. Population effects seems to come up in important ways. It's just less clear to me how that is going to guide us. And doing things in a gradual manner might matter a lot for the appeal of brain emulation. There was a reason once why Hans Moravec, for example, suggested a gradual brain emulation in mind children, because he wanted that as a powerful intuition pump, that this is something you can do and have your personal identity survive. But Tim?
Yeah. So since I have to leave pretty soon, I wanted to ask a question on a different topic to I guess people at Carbon Copies and other people at the panel can say their thoughts on this too. So we've looked at each of these questions and we've been thinking about what are the ethically relevant considerations in each of these cases. I guess my question for Carbon Copies is, are you guys planning on doing any kind of empirical research on, lay people's intuitions to try to, maybe make predictions about what their ethical judgments will be in relation to any of these topics? Because I think that could be kind of potentially useful when thinking about, for example, policy questions. What kinds of policies will people be for or against? Where are the kind of paths of least resistance when it comes to implementing some policy. So that's just a question.
In some of our previous ethics work that was done in years past, we actually did quite a few sort of polls, like getting some idea of what people think about this or about that. And I think probably going to do that in the future as well, but with more of a focus on this framework that we're trying to get our heads wrapped around. But maybe Mirinda, you can speak to it, if whether that seems like something that you want to do, if you want to collect, say, population information about what people are thinking.
Yeah, I'm not an ethicist, more of a philosopher of mind. But yeah, I would be happy to start something like that or find the people who could help me work on that.
Okay.
Yeah, so I think... oh, I'm sorry.
I just wanted to say that, so at the Institute for Future Studies, that's like something we're really interested in, is figuring out, for example, how people's level of trust in government influences their, their confidence in this or that type of climate change policy and other policies. Where, so if there's any, there might be some opportunities to either collaborate on a project or just talk through stuff.
Yeah, that sounds great.
Yeah, indeed. So as Anders kind of pointed out, it looks like there is some really practical reasoning here as to why we should probably kind of just close the event now. So the real event is closing. And thank you very much, everyone, for joining in. This conversation went in many directions I couldn't have imagined before. So it's definitely very, very useful. And I really look forward to staying in touch with all of you and proceeding further. I will stick around now in case there is kind of just post conversation between anyone for maybe another 20 minutes or so. So anyways, thank you very, very much. And also Anders, thank you so much for your moderating work. That was excellent.
Well, I've been doing my best. It's always annoying being a moderator when you have really good panels because people are making interesting points that I want to go have it to go on forever. But I do think we want to make spin-offs from this. Tim and me are thinking a bit about, could we do something over at the Institute about brain emulation later on? We should be talking more about that when we see each other. So that might pick up some good ideas. But yeah, I really hope that we can make use of the data we get here, the questions we got here, because I'm itching to work on some of these research questions. So thank you, everybody.
Thanks all. And I think this is where we're ending the recording as well, because this is the end of the official part. Yep.